This is lesson 9, interpreting graphs of proportional relationships. Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Using this information, complete the chart. So the first thing that we're going to do is we're going to create a table comparing the amount of flour used to the amount of cookies. So remember, our flour is going to be our X value because that can stand alone. So we're going to make a chart. So we have flour. That's our X value, to our Y value, which is going to be our cookies. And this is by the dozen. So the first thing we have is it just told us that we can make 4 dozen cookies with 3 cups of flour. So if I find that unit rate when I divide y by x, or divide the 4 by 3, that equals 1 1/3. So for 1 cup of flour, we can make 1 1/3 dozen cookies. So then for 6 cups of flour, we can make 8 dozen cookies. And then for 9 cups of flour, we can make 12 dozen cookies. And is the number of cookies proportional to the amount of flour used? Yes. All ratios simplify to the same number. It says, what is the unit rate of the cookies to the flour? And what is the meaning of it in the context of the problem? The unit rate is 1 1/3 over 1. It means 1 1/3 dozen cookies can be made from 1 cup of flour Now the next thing it says is to model this relationship on a graph. So when I do that, here's my x-axis, here's my y-axis. First thing we have to do is label this. So x is my flour. My y-axis is my cookies per dozen. So I'm going to label this by every 3. So I'm going to say 3, 6, 9, and 12, though I'm not going to use the 12. And I'm going to label this going up. I'm going to be labeling it 4, 8, 12, and 16, though I'm not going to use a 16 either. So for 1 1/3, to kind of estimate this, here's my 1. 1 1/3 would be about here. So 3 and 4 would be here. Let me fix that. There we go. 6 and 8 would be here. And then 9 and 12 would be here. So if you look at this, it does form a straight line, and if I were to draw a line through it, it would go through the origin. So it says, does the graph show the two quantities being proportional to each other? Yes. and it says explain. So yes, it forms a straight line and goes through the origin. It says write an equation that can be used to represent the relationship. Well, our unit rate is 1 1/3, so we would write y equals 1 1/3 x. We could also write, or y equals 4/3 x, because I could rewrite this as an improper fraction. Next. The next question says, below is a graph modeling the amount of sugar required to make Grandma's special chocolate chip cookies. Record the coordinates from the graph, and what do these ordered pairs represent? Well, the ordered pairs that we have are 0, 0, 2, 3, 4, 6, 8, 12, and 12, 18. They represent the amount of cookies per dozen that can be made with the number of cups of sugar. Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Plot the point on the graph above. Well, if I take 3, remember y over x. If I take 3 and divide that by 2, I get 1 1/2, or 1.5 dozen cookies. So now if I go to plot that on the graph here, if I go to 1 and I go to up to 1 1/2, it's going to be on this line, and it's going to be right here to plot that. So now it says, how many dozen cookies can Grandma make if she has no sugar? Well, the answer is none. It says, can you graph this on the coordinate plane provided above? Yes, I can. It says, what do we call this point? We call this point the origin. And that point, just so that you know, is the point 0, 0. So next, it says the graphs of different proportional relationships have different points, but there are 2 points that must be on every graph of a proportional relationship. The first point is 0, 0. The second point is 1 comma R. That R represents the unit rate. So the first point describes the change in a vertical distance for every 1 unit change in the horizontal axis. So basically all that means is it has to have the unit rate on there. That's all that means. The second point indicates that when there is 0 amount of one quantity, there will be also a 0 amount of the other second quantity. In other words, the origin must be on there. That's what that's saying. That ends today's lesson.